The space ecosystem is evolving in real time. As opportunities rise, challenges rise to meet them. Investors, innovators, and integrators must all grapple with tomorrow's hard problems today. How they respond will determine what's next up in space. In this episode of Nexus, surviving the development valley of death is one thing, but when are mature technologies truly ready to fly to space? Aiding in the leap of faith it takes to clear the deployment valley of death are testing facilities on Earth. What does it take to propel critical capabilities to the edge of flight readiness? How testbeds and proving grounds can beat the flight-proven paradox. Here in the Nexus, presented by Aerospace. And you're in the Nexus, courtesy of the T-Minus Space Daily podcast. I'm Parker Wishik at the Aerospace Corporation. Today, we're talking testbeds and proving grounds of the propulsion persuasion with Jaydee Dyess, Director of Test Operations for Agile Space Industries based in Durango, Colorado, and Aimee Hubble, who until very recently led the Propulsion Science Department and our test facilities here at Aerospace. So let's get right to it. Jaydee, testing capabilities are mission critical, particularly for propulsion. If you can't fly, you die in space. Now, this isn't all Agile does, but it is a core part of your DNA. Can you talk about your testing capabilities and how you've extended that as a service beyond your own enterprise?
Yeah, it's really important. It's how our whole company started, testing for people before designing. We have two stands here that are pretty much high vacuum test stands for hypergulls. So we drive a vacuum with a really big nitrogen rocket that we fire the rockets in, and that simulates a high altitude environment, similar to what they would see in space. And then we could fire the rockets there. We're kind of expanding overall throughput and how many stands we have out here in Durango. We're doing test stands in Oklahoma now as well, and expanding on how long we can fire it to kind of target some of the recent failures that you've seen in space that have been pretty prominent, and then kind of being able to cycle through as much as we can in both duration and quantity.
And this isn't just expansion in a vacuum, pun intended. There's demand for these capabilities, right?
Yeah. I have a lot of people asking if they can get on our test stand. We're booked out pretty much all the time. I try to break people in as we can.
You've even had folks send people your way because their capabilities were maxed and the queue was too long.
Yeah, that's kind of what's going on now is a lot of DPAS programs are eating up a lot of the government facilities. So they're kind of national security assets. And so we're trying to fill the gaps for anybody, all the way top of the food chain to brand new startups. Everybody's looking for a place to test.
Excellent. So, we can't just stand up these stands overnight. Aimee, you oversaw some pretty intense construction here at Aerospace, some impressive expenditure of resources. What actually happens inside these test stands, and what goes into ensuring that they're always providing access to a space-like environment?
Yeah, so I was involved with the construction of what we call EP3, which is our latest electric propulsion test stand. And there's a lot of similarities, actually, to what Jaydee just described. For electric propulsion, you're pumping on typically noble gas, xenon, krypton, argon. So these are also very large vacuum chambers. And the key design driver is actually pumping speed, because you need to basically remove all the propellant that you're sending through the thruster in order to replicate the background of space. In our case, this involved a multi-year campaign of designing custom pumping systems along with an absolutely massive chamber. This thing is 14 feet diameter, 30 feet long, has some very impressive and complicated, I'll say, accoutrements, add-ons that are tremendously useful to all of the customers that we deal with. And again, a lot like Jaydee said, we are working with folks from all over who want to come and use these facilities. It's unique and provides a really vital service. But it's tough and expensive and timely to set these up. So it's important that they serve a broader purpose in the enterprise, not just for aerospace, but for all of the companies and stakeholders that are involved.
So all these folks that are knocking down your door to get into your test chambers, they all have the same exact needs, right? It's carbon copy this test to this test. I'm understanding that right, Jaydee?
I'm hoping someday in heaven that's the case. But no, every single one, Like you'll set up an entire, multi-million-dollar setup, and then the next guy will show up and they need something just a little bit different. You've got to redo the whole thing. And then there's, they want to test the next day and think that their changes are minor. It's everybody's custom every single time. It's wild.
So you're not done once you've developed these stands, then you have to customize. How much demand would you say, Aimee, what percentage of the demand for testing requires that customization?
Probably 99%. There's always something. We've started developing techniques to try and standardize a bit of our testing approach, but typically when companies are looking to come to some of the, like our facility, they're at a point where they may be looking for something, I'll say, very bespoke or specific. They need that top tier pumping speed. They need a unique diagnostic. And so it usually almost always ends up being just slightly different, or sometimes really different from the testing that we've done before. And that's another value that's provided by these testbeds and proving grounds, is the ability to tailor the test campaign to the specific needs of the customer.
Do either of y'all have a favorite customization anecdote that you are allowed to share?
I have one. One of the requirements that somebody tried to flow to me was to put a super high-speed camera in the plume, looking up the throat, and just being like, "It's a rocket." Like I can't do that without just destroying. Like, what about a mirror? I'm like, it will die too. You can throw all kinds of things in the plume, and it will die there.
So you're saying there's a business case for indestructible video that can actually live in the plume. So
I think GoPro's got a start on it, but yeah, pretty much. Like it's pretty wild.
Aimee, I know that one of the chambers that we have, Mud Pie, and you have to answer how we came to call it Mud Pie, is one of your sandboxes, if you will, among our propulsion suite.
So Mud Pie is a new facility. It's actually a small facility that we put together in order to kind of be able to rapidly respond to unique test challenges. And the name Mud Pie came about. We have a kind of a theme in our lab. A lot of our chambers are named after types of pie. And this is the chamber that we intended to be our kind of dirty propellants chamber for EPs. This is where we might test multi-mode propulsion, or other things that we don't necessarily want to spew on our very expensive, very custom cryo pumping system that we've got in the big chamber. So for this chamber, we had to essentially, I'll say, pull together a custom pumping system on our own in a couple of weeks to support an upcoming test. So it was challenging, and it worked surprisingly well. So it's important. We've talked a lot about these huge bespoke chambers too, but it's also really useful, we've found, to have a lot of different options to be able to flex to the specific need of a test that we might have.
The Jaydee, yeah, and noting Agile has named its test stands after mountains in the vicinity of Durango. You'll have to tell us what the names are going to be in Oklahoma. For
Black
our
Mesa facility.
Okay, all right, perfect. So we want to differentiate for listeners who might not know between chemical propulsion or chemprop and electric propulsion or EP, Aimee used earlier. Agile kind of specializes in the chemical propulsion. That's, for high thrust, short duration propulsion in space. EP, a lower thrust, longer duration burn. Am I right on that, or any nuances to add to that?
Aimee, you want to go?
Sure. So I do kind of use the metaphor that EP is your Toyota Prius and chemprop is your F-150. We're starting to see, I'll say, a little more overlap potentially between the two. Fundamentally, chemical propulsion is relying on some kind of chemical reaction to create your thrust, and electric propulsion is relying on some kind of electrostatic, electromagnetic force to create your thrust. And usually that involves forming a plasma and using that kind of as your propellant, whereas chemprop is running on a chemical propellant like hydrazine or otherwise. There can be definitely some different challenges in designing a chemprop facility versus an electric propulsion facility. But fundamentally, they do share a lot of similarities. You're ultimately just trying to replicate your operating environment for your thruster, and you may be trying to make some of the same kind of key measurements like thrust. You might be trying to characterize the plume, or observe, the effect of running the thruster on, materials that are around it, any number of things. There is some definite overlap there.
So Agile's trying to make some waves here. Speaking of the overlap, I believe I read the press release that y'all are aiming for a dual mode propulsion, combining the EP and ChemProp capabilities, and y'all use the word audacious. Tell me about that, Jaydee.
Well, yeah, you'd be kind of combining the technologies and using a decomposed chemical prop, hydrazine, to be able to provide the gases that the EP needs. And so rather than having a system that goes up that has, a hydrazine tank for, delta V maneuvers and then xenon and be able to do something else, you just run on one propellant and then you use something to decompose that, and then you can do a bimode or dual mode. So you can run on a monoprop or even a biprop, which we have an engine that can do both of those, or gasifying your hydrazine to be able to supply an EP thruster. So you kind of have what we're all kind of looking for is a holy grail of like the Prius and the F-150 being able to do both. Well, we might as well probably have that in space before we have that down here with what we're working on. But it's definitely audacious.
Another audacious thing, you're supporting this kind of movement by the U.S. toward these responsive launch missions. How has your testing capability in-house enabled you to be part of the Victus Haze mission, which is the latest in that series of responsive missions?
We've touched a lot of that. Testing has been a big part in that, in being able to develop the thrusters quick, but then also our fueling services. A lot of that is being able to provide fueling services. And now we're doing like mobile clean rooms to be part of that mission to kind of, go wherever they need to. And so our testing services are more in validating that those processes work, and then providing people who are experienced in working with hypergulls and helping kind of guide the design process for like the mobile clean room. The thrusters specifically associated with that, and like trying to develop them as well. But the call up on that's going to be, pretty wild on how we end up supporting it.
We're coming to the end here. Want to offer both of our guests an opportunity to make a final point, call to action.
So one key thing to remember with testing is that it only ever gets you so far. It can be a key tool to help you cross the TRL valley of death, but at some point you've got to take the leap. And you've got to just fly the hardware. And it's a matter of risk tolerance for our customers and stakeholders, how far they want to take that testing versus when they're ready to kind of take that leap and pull the hardware into space.
Jaydee?
I think it's a great point. That last leap is kind of the most terrifying part, but you got to test. Test is critical to be able to know the next steps. Generally, when we're doing these, design validations or experimenting with stuff, you struggle into something, and when you do it in test, you can figure out what the next step is supposed to be. So I kind of preached to our team here of like, you want to be the best at test so that the design knows the next step they're going to make is the right step.
Excellent. So for propulsion testing, contact Agile, contact Aerospace. There are other test beds and proving grounds that are being collected and are accessible to the commercial enterprise. The Space ISAC is an example of an organization that's consolidating those resources. We'll provide some links in the show notes. Thank you, Jaydee. Thank you, Aimee. Thank you, T-, and thank you for listening. And we'll catch you next time in the Nexus.